Ladies and gentlemen, welcome to the 2015 Mars Society Convention. If you are on social media, please use the hashtag MarsCon2015. It's listed all throughout the center here. I would like to welcome Dr. Doug Plata, MD. He will be talking about the strategy for the simultaneous initial settlement of the Moon and Mars. And there will be a short, just few minutes of time for questions afterwards. So welcome, Dr. Plata.
Thank you. I'm going to jump right into it because we got a lot of territory to cover. So basically, I'm going to be making the case that we can and we should send humans to settle both the Moon and Mars essentially simultaneously. And I believe about the only way to do this is to really identify ways to be able to reduce the cost of going to the Moon and reducing costs of going to Mars, so we can fit both of them within essentially a flat NASA budget, which I think most of us consider is likely. And then I'm going to make the case that the initial crewed missions to the Moon and Mars, and I really mean like the first missions, really should be not so much for the purpose of doing geologic expeditions, but actually should be to establish a permanent foothold at each of these locations, even with the very first crewed missions. In regards to advocacy, and this is sort of the thrust of my presentation, I'm going to basically make an appeal at the end for a true partnership between lunar advocates, which I am a lunar advocate, and Mars advocates, which I presume most of you here are Mars advocates, to have a true partnership and that we work together to identify what is a strategy to be able to do both within the same budget, as opposed to doing things like saying, let's go to the Moon first and then Mars later, or forget the Moon, it's not our final destination, Mars is the final destination. I want us to work together and have a joint proposal that we can advocate together. I'm also going to touch bases on, just very briefly, inflatable habitats, which I think are going to be an important part of being able to establish a permanent base at each of these locations from the get-go. So I'm going to be advocating going to the Moon using a public-private program approach, which I think can be very inexpensive, and then more of a governmental international approach to Mars. But taking early steps. For the Moon, I'm advocating to develop the technology, basically modify cryogenic upper stages to be able to access the Moon and be able to do it in a rather inexpensive sort of way. And for Mars, my personal advocacy is that we do it in steps, that we do it very early, like as soon as we can, do a flyby, followed by a combined Phobos-Deimos mission, and then immediately follow with a crew to the surface of Mars. And in terms of the habitats, I'm basically recommending that we use very similar approaches of putting habitats within a crater and then telerobotically covering it with regolith to be able to provide an environment where the initial crew has the option to return to Earth but doesn't have to take that option. In fact, the goal would be for them to stay for a longer period of time. Okay, so I wanted to, being a lunar advocate, primarily a lunar advocate, I want to go ahead and draw your attention. Many of you probably already know this, but I think it's critically important to understand the role, the importance of going to the Moon. As you guys probably know, the poles of the Moon, there are areas of permanently shadowed craters. Back in 2009, NASA had launched the L-Cross mission, and it separated the spin upper stage from sort of the satellite, and the spin upper stage hit a permanently shadowed crater, Sabius crater, and kicked up the icy regolith into the sunlight. And the satellite, just before it crashed, was able to image and was able to determine the composition of the icy regolith there at the pole of the Moon. And what it found was, it found water, it also found carbon monoxide, it found some other species, But included in the other species is ammonia. So you have CHON within the ice. And this is data. It was suspected and it was proven. So I think that this is something that does need confirmation on the surface. But this is how it's looking right now. From the Apollo program, we know that we have a great deal of other minerals, including potassium and phosphorus, which of course are important for plants in the rocks called creep. For life support, L-Cross found that of the icy regolith, 5.6% was water ice. That comes to 1 part per 18, which in terms of ore is really quite high. So for life support, we can think about water and electrolyzing it so we get our water and oxygen. So right there with the water is a great source of life support. What's very interesting is if you take a look at the amount of water, carbon, and nitrogen that was shown in the L-Cross, again, these numbers need to be confirmed by the Lunar Resource Prospecting Mission in, I think, 2020. But if you take a look at what L-Cross tells us about these constituents, and you compare it to if you just sort of stick a plant in a blender and take a look at how much water, how much carbon and nitrogen, they're really not that far apart. So actually, if we were to establish a crude base and be able to recycle the nitrogen while we are electrolyzing the water into propellant, I believe that there will be sufficient carbon and nitrogen to support a base. Obviously, water can be electrolyzed into hydrogen oxygen. We can do a chemical reaction with the carbon monoxide and produce methane as well. But we could really seriously begin to think about producing propellant for cislunar transportation. Fortunately, and this is actually an advantage of the moon, there are peaks, so-called peaks of eternal light, where they get up to about 90% of the lunar day is sunlight, and that's unusual to be able to get that quantity of sort of high-power sunlight. And that would be, of course, very handy for a permanent base. So just a summary of resources of the moon: nearly continuous power, solar power, drinking water from the ice, air, fertilizer from the ice as well for food, organic chemicals. Within the dirt, there's micrometeorite bits of metals. You can make some glass, ceramics. And another resource is, because of the proximity to the Earth, we can do telerobotic operations using people on Earth, large-scale telerobotic operations. And it's not listed there, but very importantly is proximity to markets, especially orbital servicing of satellites, boosting satellites, circumlunar tourism, lunar surface tourism. These sorts of things are an advantage of the moon. So one point that I'd like to make is the moon is a legitimate destination in its own right. Okay? But then, so is Mars, right? So let's talk about Mars. Just briefly, Mars has some distinct advantages. In particular, it's got this wonderful atmosphere which has plenty of carbon and nitrogen. There are places on Mars where it seems like just under the dust, there's a significant amount of water, so water's pretty easily accessible. And in fact, I would admit that life support on Mars is more easily accessible than it is on the moon. And also Mars, it being larger than the moon, it provides greater amount of gravity. And we don't know what the gravity prescription is for health, but certainly more gravity is better than less. So basically, I'm recommending that both Moon and Mars are legitimate destinations in their own right. I can't imagine us going to one and forever ignoring the other. So I say let's do both. But as space advocates, and this is my appeal as a lunar advocate appealing to Mars advocates, I'm saying let's not fight against each other. Let's see if we can find out a win-win solution that we can both advocate. My proposal for establishing a permanent base on the moon would be what I call lunar COTS. COTS being like commercial orbital transportation system. This would be a public-private program by NASA, very, very analogous to our current public-private programs. COTS, commercial resupply, commercial crew programs. Those have gone from about 3% of NASA's budget now up to about 5%. And I think that is a reasonable amount of money in the budget, the annual budgets, to be able to fund the transportation systems, the lunar landers to be able to land on the surface of the moon, and to also develop surface hardware to harvest the lunar ice based upon the specific on-the-ground findings that we expect in a few years. And then, like University of Arizona has done work on lunar greenhouse, inflatable habitats. This sort of approach is, I think, a low-cost approach to lunar development and lunar settlement. For Mars, what I'm advocating is we start just as soon as we can with the Mars flyby mission. I think that from a human factor standpoint, I think it's very doable. And then I know this is controversial, but I think that the moons of Mars would be a very fascinating, very inspirational mission. I recommend that we don't go to just one, but we actually go to both, because the delta V between Phobos and Deimos is pretty small. And I think that we could be able to visit both, and I think that we should. But we don't stop there. The purpose of going to Phobos and Deimos is to visit those moons. But telerobotically, I don't think that we should do low latency science telerobotics on Mars during this mission, but rather do telerobotics on the surface of Mars, but by preparing a base, simple inflatable habitat in a crater, telerobotically covered with dirt, and get the equipment going inside. That should be the focus of the telerobotics, so that we have to go to Mars after we go to the surface of Mars, after we go to the moons of Phobos and Deimos. That we, going to Phobos and Deimos is not sufficient. We have to take the next step, which is humans to Mars. Okay, so for policy for the moon, I have developed a Lunar COTS petition at lunarcots.com recommending this low-cost approach to lunar development. There's been a number of people who have signed the petition, over 500 people. If you want to check it out, it's there at lunarcots.com. I'm not going to get into the details, but just briefly, the top is the commercial programs, the public-private programs, and what I'm recommending is we just do what we did and we just repeat it, but this time for cislunar and lunar surface. So that's the Lunar COTS concept. And we have very good numbers. The costs are very well constrained. There's not budget overruns. And we know the amount of time it takes to do these different things. I think we can very accurately predict what sort of a program the Lunar COTS program would be like. Very analogous, the current programs and then the Lunar COTS programs. The only difference is lunar surface operations on the moon, for which there's no equivalent today at the International Space Station. So the development, the key thing is the development of the lunar lander. United Launch Alliance has made a proposal to simply modify the well-experienced Centaur upper stage. Maston space system is actually received a couple of Centaur upper stages that they have there in Mojave. Give them probably about $50 million, and they could create a sort of a full-scale lunar lander going through the whole lunar propulsive maneuvers there in Mojave. So it would look something like this. For the lunar surface hardware, the environment in these permanently shrouded craters where the ice is a unique environment. But that environment can very much be simulated in labs here on Earth. In the Space Power Facility in Plum Brook, Ohio, we can get the vacuum and the cryogenic temperatures. We can have lunar regolith. We can suspend 5/6 of the weight. We can do 3 seconds time delay. So within that environment, we can go ahead and get the hardware working and finding out how to do telerobotic repairs and keep it going. So if we can get it working in the laboratory environment, we have a good shot that when we send it to the moon, that it would work there. There's the Resolve rover and program in about 2020 that's actually going to characterize the physical nature of the ice. Did want to mention about inflatable habitats, which would be of use both on Moon and Mars. And the amount of mass of really large habitats, you could get about 2.5 tons, and that would be sufficient for a crew of about 8, included enough space for indoor greenhouse. So my proposal, which I call Cislunar 1, launching a Falcon Heavy, delivering the reusable cryogenic lunar lander to the rim of a crater, setting up solar panels on the peak of eternal light, or so-called peak of eternal light, hop the lander from the crater, draping a wire, including possibly superconducting tape from the power in the surface down to where the volatiles are, having the ice harvesters telerobotically operated, having a dexterous telerobot to help with repairs, designing the system so that repairs are most simply done, and then conducting flights throughout cislunar space to begin to provide transportation, propellant service throughout cislunar space, providing propellant and partnering with our asteroid friends to say, let's have a program where the supply service is being delivered from either location, either the moon or asteroids. And then actually beginning to service satellites, boosting them and deorbiting them and things of this nature. And then eventually, in the long run, not the short run, but providing the materials that our space solar power friends and O'Neillians would love to have. So I think there's a lot of commonality between the different groups. Now for the policy for Mars, as we're looking at doing this simultaneously, would be, I think step one would be a flyby. I would like to do this really just as soon as possible. I would love to see a flyby in 2021. And the deal is, as Dr. Zubrin points out, is why a flyby mission is to kill the paper dragons of human factors, specifically the radiation and the hypogravity. Valery Polyakov has the longest single flight in space at 437 days. If you look at Mars 2021, it would be 589 days to do a flyby. He has already spent 74% of that time in zero gravity. He's doing fine. I don't really think that's a showstopper at all. It's the radiation. He experienced much less of that, and I think that's the bigger factor, and that's generally recognized. Tether and spin up if we need to do that on the longer missions. I've done the calculations of how much propellant it would take. It can fit within the mass budget. The radiation at different locations, certainly free space is the highest. But here's a graph from NASA showing that if you can get, for water, if you can get about 51 centimeters thick of water-bearing provisions, like your food, if you have your crew, during their sedentary time, they're basically hanging out in the pantry with their food around them. That food, if you can get about 50 centimeters thick, is going to reduce their GCR exposure down to about 2/3, and their solar cosmic rays almost completely eliminated. So I think you're getting down to about a reduction of about 80% reduction in your radiation, which would keep you well within the career limits. I mean, this is how I interpret the data, so maybe I'm not interpreting it correctly. But the idea is to have people sort of spending their sedentary time within that area. Okay, so my appeal, because I'm running out of time, but let me just sort of jump to the conclusion. My appeal is I can share about how I think we can go to the moon, costing about 5 to 7% of NASA's budget, which I think leaves sufficient space for budgetary space to be able to do Mars missions. My question is can Mars Advocate counter with an equal, I mean not at the same level, but also a low-cost approach to the moon, to Mars, I should say, so that we can both work together and be able to have this win-win and be able to achieve both destinations. I would like to say it would be nice to be able to take a look at Falcon Heavy, 53 tons to low Earth orbit, clustered ion propulsion to spiral out to an EML2 staging location. I think we can be able to not require so many heavy lift vehicles if we use that approach. So I think my time is up, but I think we have about how much time for Q&A? 5 minutes? Okay, let me open the floor. Yes.
At the Human Mars Conference earlier in the year, NASA was explaining their current concept of operation, which is Mars is not in less than years is the best. You may want to plug that into your calculation. The question is, I don't think they can do that.
So I personally think that we ought to look at sort of what we have and say, what we have in the near term. Vasimir, there's the whole power plant that's necessary for that, which is a huge issue. Obviously, Dr. Zubrin has challenged Dr. Franklin Cheng Diaz, to debate several times. Apparently, they've certainly funded it. So I would want to look at what can we do with these Falcon Heavies to a staging point at EML2, and then for the flyby and for the Phobos Deimos mission. How much of that could be done with these low-cost approaches? And then if we need a heavy lift vehicle, then we need it to go send people probably to the surface of Mars. But I'd say even if we do need the heavy lift vehicle for that, how many heavy lift launches can we eliminate by doing some of these lower cost Falcon Heavy spiraling out with ion propulsion to EML2? That's what I would like to see somebody in the Mars advocacy world really put together, that architecture to show how can we go at like 1/3 the cost or more. I think that gentleman way in the back had his hand up next. Oh, no, not pause. Flyby is flyby. Yeah, free return. Yeah, I think that would be the safest way. Okay.
When you go there first time, do you give spin gravity to during the trip so that these people maintain their physical fitness? I think it's ridiculous that all the research so far has been in zero gravity, and that's not the way to keep people healthy. If you're going to go out and then circle back in and come back to Earth again, that's a long period of time without proper artificial gravity.
So for me, the first step to Mars would be a flyby. And if we did in 2021, it's 589 days. Polyakov spent 74% of that time. I'm not convinced you even need to spin up, tether and spin up on that mission. But the Phobos Deimos mission and the Martian surface missions, they're about the same length of time. We may want to go ahead and look at artificial gravity. And you can tether tether mass is low. You can have a long tether, and you can get within your 3 RPMs or whatever the research shows is necessary for that. Next question. Okay, right there. Yeah. Okay, no, it's not that one necessarily gains from the other, but we can achieve both without delaying each other. In other words, I don't like the idea of we need to go to the moon to be able to get propellant so that now you guys can go to Mars. I don't want to put the moon on the critical path to Mars. But I really also don't like this. It's commonly said by Mars advocates, and that is Mars is the ultimate destination. If we develop vehicles to land on Mars, then maybe we can use those to land on the moon. That's not the most efficient way to go to the moon. So I'd say win-win is where we both get what we want, not necessarily helping each other, except in advocacy by having a joint program to show how can we both reduce our costs, but we're doing it for our own goals. And that's what I would say. One more question, or are we done? Right over here. Yeah, I'm aware of his dragons to Mars, and I think that would definitely qualify as a low-cost approach to Mars. So that would be compatible. That would be a win-win situation. What I haven't heard is it's a very minimalist program. It's like using short people, 3 short people or 2 normal people. But I think there's something to work with. But I don't hear NASA advocating that. And we need to have this turn into real policies that we both can win. Okay. Final thing is if I'm coming from the moon side, I'm looking for people to come from the Mars side. Let's connect, exchange email addresses, and let's see if we can develop a win-win joint proposal. Thank you for your attention.